Welcome to 6.6 Math Moment. Today students looked at more comparison problems where they were trying to decide between division and multiplication based off the real world situation. So these problems that we're going to look at today, some of them have keywords that really help us and help us to know, hey, you need to times, or hey, you need to divide. But some of the keywords are often tricky and tell us actually to do the opposite. So it's really important not just to focus on the keywords in this unit and this lesson, but also to focus on the situation and deciding what needs to be bigger, what needs to be smaller. So let's take a look at example 1. It says the tree in the backyard is 5,500 meters tall. The neighbor's tree is 15 times as tall. How tall is the neighbor's tree? So I'm not looking for anything that has to do with my tree in the backyard. I'm looking for how tall is the neighbor's tree, which it gives me a hint here. It's 15 times as tall as the other tree I'm talking about in this situation. So even though this says times big in our face, and I said before that sometimes it's going to be tricky, this one actually is simpler because when we're thinking about it, okay, I've got this tree in the backyard. In my backyard, my neighbor's tree is 15 times as tall as mine. So I know that I want it to be bigger. When I think about making something bigger, I do think about multiplication. So I'm going to take 5,500 times 15 to solve this problem. Now, when I think about multiplying with decimals, we remind the students just to completely ignore the decimal until the very end, and then we'll put it into our answer. So 5 times 5 is 25. I carry my 2. 5 times 5 again is 25, plus 2 is 27. I place a 0 to hold the place, cross out the 2 and the 5 because I'm done working with them. 1 times 5 is 5, 1 times 5 is 5 again, and now I get to add. 5 plus 0 is 5, 7 plus 5 is 12, 2 plus 5 is 7, plus 1 is 8. I have 2 numbers behind my decimal in my answer, so I want 2 numbers behind my decimal in my answer. Excuse me, I had it in my problem, and now I want it in my answer. For a final answer of 8 and 25 meters tall. Now, I need to stop and think, is that reasonable? Is 8 and 25 15 times bigger than 5,500? And yes, it is definitely bigger. Okay, when I think about 5,500, I know that's about half of one whole. So I'm looking for about half of 15, which would be really close to 8 and 25 So again, I'm just looking for a bigger number, and that makes sense. So example 2 says that Quinn's family has 6 pets. This, and when they say the word this, they're referring to the 6 pets, the information that they just told us. That can be really tricky for students. They don't think about what the this is. But when they connect it with the number, it starts to make a little more sense in the problem. So when they say the word this, they're talking about the number they just referred to, the 6 pets. So 6 pets is 1/3 as many as Kevin's family. So how many pets does Kevin have? So I'm looking for the amount that Kevin has, and he only has 1/3 as many. This 6 is 1/3 as many as Kevin. So when I'm thinking about that, 6 is only 1/3 as many as Kevin has. Kevin has more. So I really want my answer to be bigger. So when I'm thinking, how do I make, when I'm working with a whole number and fractions, bigger, when I have fractions, actually the opposite occurs. So if I were to multiply these problems, I would actually get a smaller answer. So I don't want to multiply. As many helps us know that we want to divide. So I'm going to take 6 divided by 1/3. When I divide with fractions, I always put my whole number over 1, and then I do what we call keep, change, flip, which you might remember from a few units back. So I'm going to keep my 6 over 1 exactly the same, change my division to multiplication, and in order to do that, I have to flip my last answer. So instead of 1/3, I flip it to 3 over 1. Then I get to multiply top times top, which would be 18, bottom times bottom, which would be 1, and anything over 1 is just that number as a whole. Now, I was looking for my number to be bigger than 6. This is bigger than 6. It's 3 times as big as 6, which makes sense when I'm thinking about the opposite. 1/3 as many is the opposite. So I'm looking for that bigger number, which makes a lot of sense here with 18 pets. Comparison problems can be really tricky, so if you have questions about this unit, make sure to see your math teacher.